Last one. We'll take 8.2. We'll look at this weird problem, all in terms of x, about the y-axis. So once again, this will be our final example in surface area. So this is weird. We have everything in terms of x's, but we want to go about the y-axis. What's nice about surface area is we have some wiggle room. We're able to do a couple things. So let's look at our formulas. And we're given, if you just look up top, a little circle here, right in here, it's saying that we have 2 pi integral from a to b of x times this little ds. Well, it's the derivative of the arc length, this little s, which we see is over to our right, which can either be equal to the square root of, let's get that off, the square root of 1 plus dy dx all squared dx, or we could have it as 1 plus dx over dy all squared, but with respect to y. But we have everything in terms of x's, so let's leave everything in terms of x's. By putting the two things together, we end up with an integral that's all in terms of x's. On our line with s is equal to 2 pi from a to b of x, and then we put the purple and the green together, and we can see that we just get one formula. So let's go back to our problem and see if we can't use this. And there we go. Go away, please. Next. Alright, so let's take what we got here, our y's. So it looks like we need to find our dy dx, and furthermore, well, I think it's probably a good idea for us to find the 1 plus dy dx all squared. So if y is equal to, what do we got again? It's 1/4 x squared minus 1/2 ln of x. Let's go get our dy dx. This is my second time through the problem, because the first time I screwed it up badly. This time I'll try not to do that. So the derivative of 1/4 x squared is 1/2 x. So let's just write that as x over 2. And then the derivative of 1/2 ln of x is going to be 1 over 2x. Cool. Now let's go through and see if we can't find that 1 plus dy dx all squared. And it's going to be that same stupid trick. That same thing that just keeps happening if you're paying attention. It's the same silly trick. So I wrote squared as just writing it twice and then foiling it out. And we get x squared over 1 plus x squared over 4 minus 1, not 1/2. Well, it will be in a second, but if we do these, that's 1/4. We do this one, we get minus 1/4. And then our last will be 1 over 4x squared, giving us 1 plus x squared over 4 minus 1/2 plus 1 over 4x squared. And there's that silly game again with the 1 and the negative 1/2, where now our center is not a minus 1/2, but a positive 1/2, which means we have a perfect square. These problems are cooked up, and they're a little silly. So we find out that this is equal to x over 2 plus 1 over 2x, all squared. So convenient. Alright, so let's start plugging in and finding out what our values are going to be. Move this over. Let's start solving. Alright. I left my B behind. Alright. So we're doing the integral from 1 to 2 of x times the square root of our 1 plus dy dx, but we've already solved for that, and that's going to give us our x over 2 plus 1 over 2x all squared dx. And we're allowed to square this with the square root because our bounds are going from 1 to 2, and everything's going to be positive throughout. So let's start tackling it. Let's zoom in and let's go. 2 pi from 1 to 2, we have x times x over 2 plus 1 over 2x dx. This is probably the simplest of all of them to integrate that we've had so far. We have x squared over 2 plus 1/2 dx. Simple power rule. Let's get it. And we end up with x cubed 326 plus, just call it x over 2, evaluated from 1 to 2. And let's find our solution. So 2 cubed is 8 over 6 plus 2 over 2 minus, let's slap our 1's in there, 1 cubed is 1. That's 1 over 2. Let's just make a common denominator for all of them, and I think we'll be through. 8 over 6 plus 6 over 6 minus 1 over 6 minus, and let's give it a 3 and a 3. What do we get there? 8 plus 6 is 14, minus 1 is 13, minus another is going to be 10. So we get 2 pi, and 10 pi over 6. Well, why am I throwing a pi? 10, come on now. So now we have the 2 and the 6. I think that cancels and gives us a 3 and leaves us with our answer. 10 pi.